All right, future space engineers, listen up. Welcome to your official mission briefing. If you have ever dreamed of leaving your mark on the moon, well, your journey starts right now. We're about to dive deep into the 2026 Student Rover Challenge. And believe me, this is your first real step toward making that giant leap.
First things first, let's be clear. This is not your average school science fair. No way. The Student Rover Challenge, or SRC, is built on a truly global standard. We're talking inspiration drawn directly from the playbooks of NASA, the European Space Agency, and the super prestigious European Rover Challenge. This is the real deal, folks, packaged into the #1 space engineering project for students right here in South Korea. So here's how we're going to break it all down. This is your mission roadmap. First, we'll get into the mission itself, SRC 2026. Then we'll talk about how you're going to assemble your crew. After that, the really fun part, engineering your very own lunar rover. Then we'll get into how you actually execute the mission. And finally, we'll cover the debrief and how this whole experience is designed to launch your future. Let's get to it. Section 1. The mission. SRC 2026. Time to really understand what you're signing up for. So what is the Student Rover Challenge at its core? Well, think of it like a full-blown space mission, just, miniaturized. It's been a launchpad for young innovators since 2019, giving students an incredible hands-on experience with everything from design to remote piloting. The whole goal boils down to 3 powerful words: imagine, make, show. It is your ticket to kickstarting a career in the space industry. And here's the best part. You are not going in alone. You're joining a legacy, a whole community of innovators. For the last 6 years, 27 teams from all across the country have stepped up and taken on this challenge. That's a huge network of people who are just as passionate about space as you are. Okay, so you know the mission. Now, who's got your back? Let's move to Section 2, assembling your mission crew. Because just like at NASA or SpaceX, every single mission needs a solid team. Your crew is going to be a tight-knit group of 3 to 5 members, and everyone gets a critical real-world role. You've got the project manager, who keeps the whole thing on track. Then there's the mechanical engineer, the one who's 3D modeling and actually building the rover. Your software engineer, they're coding the rover's brain. And finally, the mission specialist. That's your pilot, the one who gets to drive this thing on mission day. With your crew locked in, it is time to build. Section 3, engineer your lunar rover. This is where your ideas on a screen become a real working prototype. So let's talk about the heart of your creation, the vessel itself. You'll start with a PVC frame. It's lightweight, but surprisingly tough. But really, think of it as a blank canvas. This is where your creativity takes over. You'll use 3D printing to design and create totally custom parts, transforming this basic frame into your own unique exploration machine. Engineering is all about making tough choices, and here's a perfect example. You have to pick a suspension system. Are you going to go with a rolling suspension, where each wheel moves on its own to stay glued to the ground on bumpy terrain? Or do you go with a pitch suspension, which lets the whole rover body tilt to climb over huge obstacles? There's no single right answer here. It's a classic engineering problem that your team gets to solve. Next up, let's talk about the rover's nervous system, the brain. You'll be using controllers like Arduino or ESP32 to program every move. You'll even get to master LoRa, which is this really cool long-range communication tech for when Wi-Fi just won't cut it. Then you'll integrate cameras and sensors, giving your rover eyes and a sense of touch, sending all that critical info right back to you. Now, you might be hearing all this and thinking, whoa, that sounds kind of complicated. Don't worry, we've got your back. The training protocol guides you every single step of the way. Phase 1 starts with the basics, building with PVC, simple coding. Phase 2 ramps it up to advanced stuff like that long-range communication, and it all leads to Phase 3, a final Maker-a-thon where you build and perfect your prototype in a full-on simulation. Okay, your rover is built. Your team is trained. Now it's time for the ultimate test. Section 4. Execute the lunar mission. This is the proving ground. Welcome to Mission Control. On game day, your team will be in a separate room, piloting this rover completely remotely. You'll have nothing but the live video feed from its camera and the data streaming in from its sensors. It's intense. And here's the absolute most important rule, the one that makes this a real challenge. You cannot see your rover with your own eyes. It's called blind driving. You have to battle things like communication lag and a limited camera view, just like the real rover pilots at NASA. Mastering this is everything. Your first big objective is Mission A, traversal. Here, your job is to drive your rover across a simulated Mars yard. And I mean, we're talking gravel pits, sand traps, steep slopes, jagged rocks, the whole 9 yards. This mission is a pure, raw test of your rover's mechanical build, its durability, and your skill as a pilot under pressure. Once you've conquered that, it's time for Mission B, Precision Exploration. This one isn't just about driving. It's about science. You'll get a set of coordinates, and you'll have to navigate to specific spots. Once you're there, you'll use your rover's robotic arm to do things like collect a sample or flip a switch. This tests your software, your navigation skills, and your ability to pull off a complex scientific task. So after the missions are over and the dust settles, it's time for the debrief. Let's head into Section 5, Debrief, and launch your future. Because this program is about so much more than what happens on competition day. See, your team's final score is based on a full mission readiness check. How your rover performs out in the field, that's only one part of it. Just as important is your production data book. That's all your detailed documentation. And the technical interview, where you have to stand up and defend your engineering choices to a panel of actual experts. And we do that because this program is designed to build complete engineers. It's not just about what you can build, but can you explain why you built it that way? Through things like tech exchanges with other teams and interview practice, you develop those crucial communication and teamwork skills that you absolutely need in the real world. This entire experience, from the first sketch to the final mission, is designed to get you ready for whatever comes next. Which, of course, leads to one final really important question. After you've built a rover, what's the next step in your space journey? Well, the best part is your project doesn't have to stop here. The Student Rover Challenge is just the first step on a complete space engineering roadmap. The skills you master here, you can apply them to designing a CubeSat. And from a CubeSat, you can even start working on a rocket. This isn't just one contest. It is the beginning of a real path into the space industry. So this is your call to adventure. The skills are there for the learning. The challenges are waiting to be conquered. And the future, well, that's yours to build. So go on, assemble your crew. Your mission begins now. Imagine, make, show.